Hi, my name is Emmy Riley, and I'm going to talk about CHP today. In the past couple of months, Cyclone has had a couple of clients who have had combined heat and power recommended to them by outside companies, and they actually were a good fit for it, but they didn't know what it was. And so I wanted to give this presentation because I like CHP a lot. I think it's a really cool technology. It's one that it's been around for a really long time, and I wanted to expose you to it. So maybe we should start with how your building gets electricity right now. It basically comes from the grid. You've probably heard of the grid or the electric grid, maybe more recently smart grid, or Joanne in California might have had a brownout on the grid. So at a really high level, power gets generated somewhere else, and then eventually it winds up at your building. What happens when it gets made somewhere else is more or less a fuel either gets burned or maybe some atoms go through fission, and that heats water that turns it into steam. The steam drives a turbine, so the blades turn on that, and then it drives an electric generator. It's not that efficient to do it that way. Where we're at right now, coincidentally, it's about 32%, between 32 and 40% efficient, depending on your fuel and technology. And it produces about 30% or a third of all the greenhouse gas emissions in the world to produce electricity that way. Switching gears a little bit, how you use heat in your building. Here in Chicago, probably the biggest way you use heat is through space heating. So you probably have a boiler or a gas furnace in your building. You probably also use it for domestic hot water heating for your sinks. And then if you have an absorption chiller, you probably use it for cooling too. It can be more or less efficient to produce that heat. On a really old boiler, it might be as low as around 50% efficient to make the heat. If you have a newer condensing boiler or furnace, it might be as high as just below 100% efficient, but as long as it's gas, it's never going to be 100. Together, those two processes also aren't that efficient. So if you have, in this scenario, it's a 33% efficient power plant and an 80% efficient boiler. And together, the overall efficiency of those systems is around 51% efficient. A more efficient way to do that, there is a more efficient way to do it, would be to have that same efficiency on the electric side, but extract the waste heat off of it and replace the fuel that's needed to be burned for heating your building with the heat that comes off of that process. And that drives the whole system efficiency up to around 60 to 75%. Sometimes it can get as high as 80. This is just like having a tiny power plant at your building. So you would have a really small version of the giant turbines they have at central station power plants. And you would have that at your facility. It would generate your electricity. You could sell some of it back to the grid if you have too much, and then you take the heat off of it to do whatever with it. This isn't a silver bullet planet saver, nothing is. But what it is a way that you can generate electricity and heat more efficiently right now at your building with less emissions, and it's a proven technology. So it's a way to become part of that larger goal. Anyone can install CHP, but there are some circumstances that make it more favorable than others to do so. Two are having a combination of higher electric costs and lower natural gas costs, and that's the bigger that difference is, it's called the spark spread. So the bigger your spark spread, the better. Also, if you have long run hours and a high thermal load at your building, those are good conditions too. Lots of buildings have those conditions, but a few really hot conditions, hot types of buildings with those are campuses of buildings like universities, hospitals, and the reliability, having CHP increases your reliability of power at your building, so hospitals are a popular place for that too. When you should definitely not consider having CHP is if you don't have a place to put any of that heat, if you can't get gas to your building, that's a non-starter. If your building can't structurally support the weight of a prime mover, that would also be a reason to not install this type of technology at your building. But a lot of other people have installed it. As a matter of fact, the first commercial power plant anywhere through Thomas Edison in 1882 was a combined heat and power plant. In the US, there are 4,100 sites that have combined heat and power right now. That's in every state, and it makes up about 9% of the US electric power generation. One that's pretty close to home is at Antioch Community High School. This is about an hour north of here. what they did is really cool, I think. There was a closing landfill nearby, and they piped the landfill gas to 12 30-kilowatt microturbines that they're building right here. And so now they save about $100,000 a year in electricity costs. To install it, this is a really important question. It can totally vary by the type of equipment that you have and the fuel that you're using, but it's typically between $1,000 and $5,000 per kW that you install. The plant that was on the last page cost $1.9 million and had a 7-year payback. You can also get money from the utilities for this, just like most things. There are 2 paths for getting that money. If you don't have a plant already, but you have a 1,000 kW demand and you have a high thermal requirement and you're interested in having this technology, they want to talk to you. And also, if you have an existing generator that's been idled for a while, you're a good candidate. Specifically, what the incentive is that ComEd will split the cost of having the initial site assessment for CHP up to $25,000. They'll also split the cost of connecting that plant to the grid up to $25,000, and they'll even incentivize the electricity you generate and your thermal output. There's one area, there's not a lot, but there's one area where the public sector totally crushes the private sector, and that's in CHP incentives. In the last 2 years since they've had this incentive, the public sector has had 17 applications, 5 approvals, and 2 constructions of plants, and the private sector has only had 1 application as of last month. That's pretty insane, so if you're interested, you should pursue it. My favorite CHP project I've ever heard of is at Snowbird Resort in Utah. My husband and I like to ski and snowboard. They installed this crazily in 1987. It cost $5.7 million to install. I swear not every project has a 7-year payback, but this one did. And they use it as a snow melt system on their sidewalks too. I thought that was interesting.